Hi, I am Ayush from Team CodedHearts, and today I want to show you something that we believe can fundamentally change how Union Bank fights financial crime. Our solution is called STAR, Spatial and Temporal Automated Risk Management System. And before I explain what it does, let me tell you why we built it. Every year, between $800 billion to $2 trillion US dollars is laundered globally. Less than 1% is ever detected. Union Bank, like every other public sector bank, processes millions of transactions daily, and somewhere inside that flow, coordinated laundering networks are operating right now, splitting funds below detection limits, routing money through chain of command, and cycling it back to origin. And your current systems cannot see any of it, not because the compliance teams aren't good enough, but because the tools are architecturally broken. Today, the anti-money laundering system do one thing. They score each transaction individually against fixed rules. And that is exactly the gap that financial crimes exploit. The fraud doesn't live in a single transaction, it lives in the network connecting dozens of them. Let me show you exactly why existing systems keep failing. Rule-based systems are use fixed threshold, and launderers simply calibrate their operations to stay below them. Smurfing, structuring, layering, all of these are designed specifically to defeat rules. And even when alerts do fire, investigators receive a risk score and nothing else. No network context, no evidence trail. They have to manually rebuild the entire transaction chain from scratch, which take 2 to 4 hours per case. So what makes our system any different? First of all, graph native detection. Star doesn't score transaction. It models every account as a node and every transaction as a directed edge in a live graph. A laundering pattern spanning 10 accounts over 5 days is as visible as to Star as a single suspicious transfer. Second, temporal intelligence. Our hybrid temporal graph attention network encodes not just who transacted with whom, but when and how fast. The time delta between consecutive hops in a direct model feature. Rapid fund circulation, dormant account activation, velocity-based structuring, all of it becomes detectable. Third, explainability by architecture. Every risk score Star produces is backed by a subgraph, the actual account and transactions that drove the alert. Investigators don't just receive a number, they receive evidence. And fourth, inductive learning. Traditional ML models can only score accounts they have seen during training. Star generalizes to brand new accounts to inference time. Now let me walk you through how this actually works under the hood. Live transactions from core banking enter layer 1. Apache Kafka and Apache Flink handle real-time ingestion and streaming. In layer 2 and 3, two things happen simultaneously. Transaction velocity features are cached in a Redis cluster for sub 200 millisecond access, and every account relationship is written into a Neo4j graph database, building the live network map in real time. In layer 4, our hybrid ML engine, a rule-based engine, running in Flink filters obvious cases first, and then the gate model runs attention-weighted message passing across the two-hop subgraph, fusing structural and temporal features to produce a fraud probability score. High-risk cases queue into layer 5, PostgreSQL case management, and surface in layer 6, and human-in-the-loop dashboard built on Fast API and React, where investigators see the full graph evidence behind every alert. And finally, in layer 7, the SAR STR generator. High-confidence cases automatically trigger a PMLA complaint report routed through our MLRO compliance review via secure API and dispatched to the FIU INT regulator. 7 layers, one seamless pipeline. Now, a natural question. Is this actually deployable at the scale? Yes, definitely. And here's why. Technically, Apache Kafka handles over 1 million events per second. Neo4j is used in production by HSBC-like banks for fraud detection. Our TGN and inference runs under 200 milliseconds under Redis caching. The entire stack is containerized and cloud agnostic, deployable on NIC or Union Bank's own infrastructure. Organizationally, phase 1 deployment requires zero changes to your existing CBS. Star operates as a passive listener on a read-only replication stream. Your current AML operations continue uninterrupted. Financially, our core stack is open source. The return on investment case is direct, recovering investigator hours from false positive rates. So, what do you actually gain out of all this? Operationally, false positive alert volume drops by up to 95%. Average investigation time drops from 2 hours to under 10 minutes. The Gen AI SAR drafting layer eliminates manual report writing entirely. Financially, STAR enables real-time transaction blocking before the funds even exit the network. Early detection always recovers everything instead of after the funds have already lost. And Union Bank directly addresses its share of India's 1.25 lakh crore annual bank fraud exposure. Regulatorily, faster, higher quality SaaS filed within PMLA's 7-day window, a full audit trail on every alert, and Union Bank positions itself ahead of AI-based AML mandates that RBI is actively moving towards. We have designed Star specifically to fit inside Union Bank's existing ecosystem, not replace it. Phase 1, month 0 to 3, we connect Star's Kafka consumer to the Finacle CBS feed via a read-only replication stream. KYC and account data flows into Neo4j. The TGNN begins running in parallel alongside your current AML system. No disruption, no risk. Just immediate visibility into what your existing system is missing. Phase 2, Star's dashboard embeds into your fraud analyst workflow portal. The Gen AI SAR layer activates. Investigators begin filing star-packed reports under your existing PMLA process. The feedback loop goes live. Every confirmed fraud case retrains the model on Union Bank's own data. Next, in phase 3, we will start covering all UPI, IMPS, and RTGS feeds, integration with civil and government watch lists, RBI regulatory sandbox certification, and preparation for consortium deployment across other public sector banks. Now, I will be presenting to you how STAR is able to identify frauds in real time by using a data provided by IBM that was used to train the machine learning model. Right now, you are looking at the STAR system constructing a real-time graph for a transaction as being fed. Each new transaction is ingested in real time through Apache Kafka and immediately written into this graph. As you can see, accounts connect to each other, relationships are formed, and the network grows. Notice how quickly the topology takes shape. Accounts that transact frequently build denser clusters, dormant accounts sit isolated at the edges. Now, accounts appear the moment their first transaction arrives, and Star begins scoring them immediately from the very first stage. This is something no rule based system can do. We are not looking at a transaction one by one, we are watching the entire financial network build itself in real time. The flagged subgraph is sent to our GenAI forensic layer, which identifies the motive, in this case, structuring, and auto-generates a PMLA-compliant STAR narrative with the full evidence trail attached to it. And on the investigation dashboard, the analyst sees exactly this: the accounts involved, the transaction path, the timing, and why STAR flagged it. No manual tracing is required, no rebuilding from context from scratch. Everything an investigator needs to use is already here, directly derived from the graph. Star is not a research prototype. It is a validated production architected system built specifically for the system and regulatory context of Union Bank. We have a working proof of concept, we have benchmark results, we have a clear integration path that requires zero disruption to your current operations. The intelligence gap in India's anti-money laundering infrastructure is documented, real and costly, so we have built the system to close it. Thank you for your time.